Hi guys! So for this video I'm going to go over most of the basic principles that we have learned for work and energy. The first concept we learned was the relationship between work, force, displacement, and angle. So as an example, say that I'm trying to use a slingshot to shoot clementines into Venilla's mouth. When I stretch the slingshot back, the force and displacement are in the same direction, thus increasing my capacity for work. The angle created is between the force and displacement vectors is 0 degrees and cosine of 0 is 1. Afterwards, I hold a block slightly above a clementine on a table, and I move the block to another clementine at the edge of the table. If I were to put my hand down, I would do no work on the clementine, because my force and displacement vectors make a 90-degree angle, and cosine of 90 degrees is 0. As we can see, cosine of the angle is proportional to work. Additionally, based on the observations that we make, the more force applied or the greater the distance, the more work that is done. We can conclude that the work formula is work is equal to force times displacement times cosine of the angle. The next thing we learned was about energy. So let's do a quick definition of the energies. Gravitational potential energy is the energy possessed by a system, including the Earth and an object, and it is increased by increasing the altitude. Kinetic energy is the energy obtained through motion, and it increases when an object moves faster. Elastic potential energy increases when an elastic object is stretched. And finally, internal energy refers to a random kinetic energy of molecules, which can be caused when two objects rub against each other. We also talked about transfer and transformation of energy. A transfer of energy occurs when an object comes into or leaves a system. This can occur, for example, when you do work to wind up a toy. Transformation occurs when there's a change within the energy. In a wind-up toy, when the toy is released from its winded state, there is a transformation from elastic potential to kinetic energy. And when looking at transformations and transfers, it is often helpful to do bar charts. I'm not going to draw one out right now, but it is important to remember that bar charts focus on the initial and final states. So the final two things that I'm going to explain are the formulas revolving around gravitational potential and kinetic energies. Just hold on a second. So for gravitational potential energy, we'll use the example of a dinosaur biting off Gargi's head. So Gargi's on top of a building and the dinosaur slowly lifts her up perfectly vertically at a constant rate. So the energies involved in the initial state is kinetic energy and gravitational potential energy, as well as work. Well, work is not an energy, but it's part of the equation. So in the final state, there is a kinetic energy and a gravitational potential one. Since the velocity remains the same, we can subtract the kinetic energy out. And for work, we apply the formula, force is mg, and the angle is 0. So the displacement will be represented by y sub 2 minus y sub 1. And we see that u sub f minus u sub I is equal to mg y sub f minus mg y sub 1. We can generalize that u is equal to mass times gravity times height, mass times g times height. And this is true, this is the equation for gravitational potential energy. So next, for kinetic energy, I'm going to do a plain mathematical derivation for the energy of an object which accelerates. Okay, so we start with k sub I plus w is equal to k sub f. K sub I plus fd cosine of 0 is equal to k sub f. Fd is equal to k sub f minus k sub I. So now we have to turn the terms such as force and displacement into more tangible ones such as mass and velocity. So we already know by Newton's second law that F is equal to ma, and we can manipulate a kinematics equation for displacement. So the original equation is v sub f squared is equal to v sub I squared plus 2ad. So by simplifying that, we get this. So then we substitute in f and d to get this equation, and then we just multiply the a's out to get this equation. This equation, and finally this is the equation we can generalize. Mv squared over 2 is equal to k. So I hope this helped you guys, and don't be afraid to comment below if you have any questions.